We're here. Hey, everybody. Good morning. I'm Austin Griffith. Thanks for having me here. We're going to do a little introduction to Dap Building, kind of take it easy, kind of go slowly through it. If we're ready to go and the back, I'm in a new place. There it is. There we go. We got the screen. Which way is it? This way? Yeah, there we go. Awesome. So this is the heart of Scaffold-eth. This is what I want to get into first. This is the point I want to point out. So what we can do here is we can just make a small change to our smart contract. And if I do a yarn deploy over here, we're going to see that chain show up over here. Watch this purpose over here. It should turn into more exclamation points. There we go. So that's the heart of the thing first, and I'll kind of work us outside of the onion as we go. But Scaffold-eth is a full Dap template. It has Hardhat on the back end, and then it has React on the front end, and it has tons of components and hooks and all the things you're going to need when you build a decentralized app. And some folks land here and they say, "Whoa, there's way too much stuff here. Like I want to learn from the beginning. I want to build this thing." And like you could go that route, but you're going to eventually get to the point where you're like, "Man, I needed all of those things." So we'll go through that today kind of slowly, and I'm watching the chat. So if you have questions, I see lots of GM. So the cool thing about having Scaffold-eth set up for you, where it has basically your whole Web3 stack, even things like Subgraph and things that you'll need eventually, it's production ready, but it works out of the box, and that's the trick here. So let me just back up now that we've kind of like you've seen the kind of the magic here, where we can iterate quickly on our Solidity and we can see our app kind of auto adapt to it. So let me back up a little bit and let's look just at Scaffold-eth, the repo, and talk about installation, getting it up and running. So if you Google Scaffold-eth, you're probably going to land here at the repo. Hella open source, hundreds of branches. This thing is built to be forked. It's basically one of my main metrics here is seeing weird forks of this thing in production. So if you're building something cool on Ethereum or an EVM compatible chain, I'm an EVM maximalist, you can fork Scaffold-eth and get started right away. Okay, so the installation is you're going to need Node, you're going to need Yarn, you're going to need Git. If you're not a super nerd, don't be too worried about this stuff. You can work through it. It's not that big of a deal. One little gotcha I would say is sometimes folks that are on a Linux machine will install the wrong yarn. So when you install this yarn, you want to do like npm install -g yarn, something like that, right? Don't install the like yarn executable from like your Linux package distribution. Just a quick little gotcha there. So once you have Node and Yarn and Git, you'll clone down Scaffold-eth and you'll have everything there, front end and back end. You'll do a Yarn install. It'll take a while. Scaffold-eth is pretty big. I get it. Eventually, you'll package up a static app, and it'll be a lot thinner. But there's a lot of stuff here because you're going to need it, and we'll get into that as we dive in here. Then you'll do a Yarn chain, and that will bring up your Hardhat node. Let's see if I can zoom in on this a little bit. There we go. So when you fire up your Hardhat node, it gives you a local blockchain, but it also gives you a list of accounts. And there's accounts that go along with this that are loaded up with just like hundreds of ETH, right? So you have a ton of fake ETH and you have your local blockchain ready to go and all the wonderful plugins and community and ecosystem that exist around Hardhat. Let's see. I'm kind of trying to watch the chat here, make sure there's nothing. What does, okay, we'll get to it. Okay, so that is your first command is yarn chain. Then you do a yarn start, and that brings up your React app. And there's a handful of different branches on Scaffold-eth that use a little bit different front ends. I've seen folks use Chakra. I think if you get in here and just like look up Next.js, there's a couple of Next.js, Scaffold Next.js. I don't know. What's another front end? I bet there's not a Vue one here. No, there's not a Vue one here. But if you're a Vue developer, let's put it together. I'll stream ETH to you. You build a Vue version of Scaffold-eth, and let's push it out there for other folks to fork and build on. So You can always hit the branches and find other front ends, but we've got just like a React front end. We've got our hard hat back end. And then in our third terminal, we're just doing a yarn deploy. And that's what it should say here. Yep, yarn deploy. And that's it. You can kind of just like iterate on that loop where you make a small change to your existing smart contract. There's a smart contract that comes with it out of the box, and you see your contract or your front end auto adapt to that. So whatever you're trying to learn, whatever you're trying to get into, you can kind of just like paste some, let's say we're learning events or something, right? You could paste in an event, you could set it up so it emits the event, and then you yarn deploy. And then you go over to the front end and you trigger that event and you listen for it with an event listener in the front end. Let's see. I think we have an event listener here. Oh, there's a lot more to get into. I'm just going to like comment that out. That's a tangent that we can get into. But what I'm showing here is that you can land, install this thing, and quickly start iterating and learning Solidity, kind of testing your assumptions and playing around with things. So let's look at the front end here and kind of just look at some of the pieces that you'll get out of the box, right? So right away, I want to talk about wallets. If I do a new incognito window and I point it at localhost, I love that my browser sends me to loogies. We'll talk about loogies in a little while. So you'll notice here we kind of have this like watermelon kind of colored dude, right? And then there's kind of like purple dude over here. These are burner wallets. And what that means is your private key is stored in local storage. And that's kind of sounds scary, kind of sounds worrisome, but this helps you iterate in a development environment quickly. If you've ever set up a Web3 environment and you used MetaMask right out of the box and you used MetaMask on your local development, you're going to run into issues with the chain ID being wrong. You're going to run into issues with your nonce not being right. Like if I kill this hard hat node and I restart it, my MetaMask still thinks I'm at nonce 3 or whatever, and I need to reset back to 0. So just while you're locally spinning up contracts and chains willy-nilly, and you're just kind of like poking at things and trying to get things figured out, use a burner wallet. And then once you go to a test net, once you start creating more of a fine-tuned product, then it's time to log in with MetaMask and actually have that prompt to like, yes, I do want to do that. And at that point, like you'll have a lot less issues with chain IDs and nonces because you'll be on a public network. So let's look at this whole wallet, this burner wallet thing that I'm talking about. So the first thing, we have this great big gross call to action. And I think it's really funny. I made it so obvious. I feel like some of my buddies like totally ignore it. You know how like, it's like, that looks like an ad. My brain just like blacks that out. I can't even see it, right? But this is a call to action because it's really nice because you can just hit this button and your local burner wallet is going to get some funds from the faucet. And there's also a way to go to the faucet here. There's a nice little faucet down there, right? And that faucet is basically when we spun up our hard hat node, there were like 10 accounts. And one of those accounts is kind of acting as the faucet and also deploying funds. And it's loaded too. You can get into this right here. So here, yeah, look at it. He's doing pretty well with local ETH, right? Almost 10,000. Okay, and you can, let's see. Let's go ahead and let's send ourselves some more funds, right? We're just playing with the faucet here. We're learning how this works. See how like this address input field is really nice, right? It gives us a nice visual preview of who we're sending it to. It lets us do dollars instead of ETH, right? But we can switch back and forth. All of these really nice components come out of the box with Scaffold-eth. And when you first get started, you're like, I don't need that stuff. Like you really do. Like if you want to build a production level dApp and you want to have real production users, you need to display things most likely in USD. Sometimes you'll want to display them in ETH, but most likely you'll want to say, how much do you want to send? I want to send $1,000, and you want to hit send and you want it to be done with. You don't want to have to do all the conversions and stuff like that. Same thing here. You'll notice that. And here's our wallet here. So there's two different wallets here. There's the faucets wallet, and then there's our wallet. Okay. And then there's Purple Guy's wallet over here. So let's copy Purple Guy's address. Let's go over to this guy's wallet and let's make sure we can send some funds to him. There we go. Okay, so you're getting a feel here for how the wallets work, right? We've got a burner wallet. We've got a burner wallet we're able to send around. The faucet has its own wallet. So these wallets are quick and fast and easy to use. So now that we have some gas, we're ready to tinker around with our smart contract. I'm going to go ahead and close watermelon guy out for now, and let's use purple guy to kind of poke at our contract. So what do we have? Let's look at it. We've got a string purpose, so we're storing some string. Let's see if I can make that a little bit bigger so we can see it. Okay, we're storing some string, and then we have one function that lets us set that string, right? And we see that happen here, and there's really no requirements. Basically, anyone can call this. It starts like this, and then anyone who calls it can add to it. So let's try this. Let's try a hello world, and let's hit send. There it goes, and it updates it. So it crafts the transaction. It sends it off to the local mempool, but not really. It just gets mined, right? If we were on a public network, there would be a lot more going on there. But and then it mines it into a block, right? Each transaction you make here, your local hard hat node is going to mine that into the next block, and you're going to get like these instant transactions. No MetaMask pop-ups, no nonce issues. You're quickly iterating, right? And let's just like real quick, I do this every time, but I love setting up some kind of a like a little counter just to show this little state machine and how it works, right? So if we have a counter equal to 5, and let's just go ahead and deploy that, right? Let's make sure that counter shows up. And while that's deploying, I'm going to create, let's create another function called increment. That's going to, what's it going to do? It's going to do counter plus plus, right? And let's go ahead and ship that. See how that counter showed up? Now you'll see we'll get another contract. We're deploying contract after contract after contract. But look at that. Now we added this increment function, and now we have this new increment over here. And what happens when we call that? Well, heck, it increments our counter. It's working, right? Our little, I like to think of smart contracts sometimes as like these little like low-level embedded controllers, right? You're thinking about memory storage, and you're building this kind of execution logic. Okay, let's see. Chat looks good. If you have questions, bump them into the chat. I noticed there's some other Scaffold-eth homies there helping. So yeah, ask away. So you are a developer, or you are wanting to get into Web3, or both. You pick up Scaffold-eth and you start tinkering, right? And I even have this nice, as you go through this, there's tons of documentation. Hit the docs and you'll see a video, and then just like a ton of introduction. There's a bunch of stuff to read here if you get lost. There's also a chat. If you go to this little button right here, see that support button down there? That support will take you to a Telegram channel where, I don't know, I think there's like 1,000 people in there now, like 1,000 builders, or at least, you know, hundreds of builders in there helping you kind of get built what you need to build and get your education, right? And speaking of the education, let's zoom in on that. So learning Solidity is pretty easy, to be honest. Writing Solidity is not that hard. Writing a safe smart contract system is very, very hard, but getting this stuff going and getting these mechanics where I just threw in that counter and we added an increment function, that's actually like super simple, especially if you've had some JavaScript knowledge in the past. And I would recommend that. Like I would say, if you've never programmed anything before, you should probably go check out like a Web 2 intro, right? Like learn how to write JavaScript, learn how a for loop works, learn some basics of JavaScript, and then maybe even some React. Get into React, build a little front end, build a little to-do list, build a little app, build a little dashboard, build something that you'll use, and then start using it, and then provide your own kind of product feedback and get in that loop of like, oh, you know, I've been using this thing and there's this one thing that's like a pain. Let's find that and make it better. So get into an introduction first, learn some JavaScript, learn some React. Then you're ready for Solidity. It's an easy language, and you can basically go through and learn it. If you understand a programming language or two, this is going to be a super simple lift for you. You've got primitives and data types, bools, uints, strings, addresses. Ooh, addresses. Let's address that issue. So addresses are a little interesting. Look at this. Look at that. It's like this hex string just like pasted in. Let's see. Can I make it bigger? This wild hex string just pasted in, right? Okay, so everything else, bools, uints, strings, you know what that is if you're a programmer. But this address, this is more Web3 native, right? This is more And let's just tinker with it. Let's say, how does an address work? I don't even know. Let's pull up Scaffold-eth and let's see what it does. So let's grab this dude's address and notice this nice little copy button next to the address. Every single address in Scaffold-eth is an address component, and it has a little copy button next to it, and it has a little blocky preview. And when you click on this address, it's going to take you to whichever block explorer is fitting for this. If we were on Rinkeby, it'd take us to Rinkeby. If we were on mainnet, it takes us to mainnet. So your whole app is sort of like quickly iterating, and you switch from, okay, now I'm going from Rinkeby to mainnet. It's one value. You switch one value and you're ready for mainnet, and all of that stuff in your app is going to change. And so that it's just like one of the tiny little things, and Scaffold-eth brings hundreds of these tiny little things together to make your life easier. So even if you get in here as a builder and you're like, I want to do it myself first, start with Scaffold-eth, pull it down, get into this iteration loop. Okay, let's grab this dude's address and let's paste it in here. We're going to create an address public owner, and we're just going to paste that in there, right? No quotes around it, nothing like that. We're going to hit save and we're going to deploy. Now, hopefully we should see Purple Guy kind of becoming the owner of this contract. And there's no like arbitrary owner of a contract. We're just tracking some value. We can even say, let's just call this Austin, right? Instead of calling this owner, let's call it Austin, just to show that it's like not really an owner. We're arbitrarily picking the name of this variable and setting it. Okay, there we go. There's Austin right there, right? It shows up in our contract. Now, the next piece, so we've kind of played around with primitives and data types. The next piece I want to show is just writing the first simple rule or a require statement. And that is like that this is a powerful thing right here, is we can start writing rules for how we want people to be able to interact with things. Remember, this smart contract is like a vending machine, right? It's something that anyone can get to once we deploy it. It's going to exist across thousands of nodes and anyone can get to it. So we want to kind of require who can do what, and we want to write the rules very, very clearly and explicitly. So let's just require that the message.sender, and this is a global variable. If you do solidity by example, we can get in here and find some great examples. Oh, whoops, actually, I wanted to read the docs. There we go. So the Solidity docs, and if we look at globals, you'll find all your global variables, I think, units and globally available. There we go. So you've got how to assert, you've got how to do time units, but what we're looking at here is this message.sender. So this is basically who gets in and calls that function. So we're going to require that the message.sender, we're going to require that the person that calls set purpose, we're going to say they have to be equal to Austin. And if they're not, we're going to say not Austin, or maybe we should say not the owner. This not Austin is kind of weird here, but we'll just say not the owner, and then we'll do an exclamation point, and then we'll do our semicolon, and then we'll ship our app. Now, let's test this out, right? Now it's time to audit this line of code. Do we send it to a $10,000 auditor? 10,000. If you get an audit for 10,000, you're probably getting lucky. Do we send it off to an auditor? No, we test it right here in the front end. We test our assumptions and we just try things out quickly. That's the beauty of having this front end kind of auto connected to our app and kind of auto refreshing, is we can do stuff like let's bring up localhost again. Let's bring up another burner, right? Okay. We'll call this dude red dude. We'll grab some funds from the faucet and we'll say, hey, does this work? And it probably shouldn't, right? We should probably get an error. Yeah, sure enough, not the owner. So we got to that require statement and we're not able to set the purpose. All right, see you later, red dude. Coming back, purple dude. Let's hit reload. Let's see a fresh one here. This should work! Exclamation points. Boom, there we go. So we kind of like tested that line of code, right? We kind of made sure that require statement worked. We made sure that you have to be Austin, or you have to be the owner to be able to get in and call that function. So this is kind of cool, but what you want to dive into is thinking about this, like I said, as a vending machine where anybody can get to it. This is kind of centralized. We're not centralized, but like a single person. The person who controls the private key that goes to this address is the only one that can call this function. It's cool. Maybe it's like an attestation machine or something like that. But it's cooler if you think about this more like, what if they have to pay to set this this purpose here, right? So instead of the message.sender, we're going to look at the value of the transaction, right? And we're going to make sure that that value is greater than or equal to 0.001 ether, right? And we'll get to ether and why. Oh, look at that nice little hint there. We'll also see that in a second. Yes, Scaffold-eth is kind of like a GUI to test your contract logic. You can paste your contract in and you will get a GUI for it right away. It helps you poke at your contract and learn, but then it's almost like once you've got it working, that GUI becomes the front end of your app and you can deploy that thing. So you can deploy your contract, but you can also deploy your app. I'm just trying to kind of answer some of these questions in the chat. How long did it take to get Scaffold-eth here? I don't know. We've been at it for about a year now, I think. And it's, been a lot of other people helping me. When you get in there and you see, 250 branches, that's not all me. There's a lot of people helping. Some folks on this call too. Okay, so what we're gonna do is we're gonna require, we gotta do one other thing. These functions are safe and you need to mark them as payable if you want them to accept value. But I think that should compile. Let's see. Please work first try. Boom, our contract is deployed. All right, so look what happened over here. Something changed. This new transaction value was added, right? Our front end auto adapted and noticed, oh, this is a payable function. We need to add some value coming along with that, right? All right, this is going to be test two or something, right? And this time we need to pay for it, right? We need to pay 001. And watch what I have to do here. This is a really annoying step, but I make the developer do it. I'm thinking all the time about this developer experience and how you have to go through it and kind of learn the gotchas and the ins and outs. I have to hit this little 10 to the 18 button, right? And if you've started to study Solidity at all, you know that Solidity works in kind of way. If I put a 1 here, if I say 1, that's actually one way, right? If I say 1 ether, that's actually equal to 1 way times 10 to the power of 18, right? And sometimes you see that written like that too. But that's, you kind of want to understand that underneath the abstraction here, the EVM needs to be pretty simple, so it's more decentralized. So it doesn't want to F around with floating point math. So you'll have to convert everything to way when it goes in. But for humans, we would like to read it like this, right? If there's an extra 0 there, it's going to throw us off. So humans want to see it as a decimal. The machines need to see it like that, right? And this is the exact same thing here, right? That is equal to that. Like basically those two things are equal. It's just up to you how you want to display them. All right, here we go. So now we are going to make a transaction and we are going to pay for it. And hopefully we will set the purpose to test 2. We did it. Okay, so now our vending machine is working, right? And let's go back to this homie over here that is kind of like thought of as the bad guy, right? We've been thinking of this guy as kind of us. We've been thinking of this guy. So we got like teal purple guy over here. Thinking of Ethereum as this massive multiplayer RPG, as this vending machine system, right? Anyone can be able to get to it. You have to think that everybody that can get to it is adversarial, right? You need to write your rules correctly so your vending machine works the way you want and no one can steal money out of it or even like grief people. If you can find a way to make the vending machine so it griefs someone else and the person can't get their money out or something like that, it's as good as stealing it, right? Okay, here we go. So let's try to set the purpose. Let's do a hello world and let's pay a little value and let's convert it and let's hit send. Boom, there we go. So anyone is able to set the purpose. And let's just real quick do 0.0001 and make sure we're not make sure if we don't pay enough, this should fail, right? Yeah, it shouldn't say not the owner though, right? It should say something like not enough. Right? And it's a simple change. Look at that. Change that, hit deploy. It's fixed. Cool. So hopefully you guys are getting in and seeing how this kind of works. You can iterate on your Solidity. You have a front end that auto adapts and lets you kind of poke at your Solidity at first. Your first steps as a developer are to get in here and start learning these concepts. The next concept to learn is a mapping. Mappings basically, let's see, let's just go look at what a mapping looks like, right? Okay, here is a mapping. And what I want you to do is just copy and paste that thing in here and see what it looks like. Play around with it, poke at it, right? My map, what is my map? It looks like it's a mapping from basically any address is gonna have a number associated with it, right? So given this address, here's the number that's associated with it. So this works really well, actually, for like maybe we call this balances or something like that, right? And then maybe in here we say, let's set the balances of Austin to 100 ether, right? And it's not actually ether, it's just a number. Here, instead of doing ether, let's do times 10 to the power 18. I feel like that's clearer. We're saying that I have 100 ether, not 100 way, right? If it was just 100 there, there we go. There we go. Let's deploy this thing. So we created a new storage element called balances, and we set Austin's balance to 100 ether. Now, if we come over here, we see there's this new balance thing. If I copy Austin's address and I paste it in, I get that nice blocky preview. Isn't that nice how that works? And then I hit send, 100 ether, right? See that little ETH thing there? Let's actually cut it back down to 100 just real quick. Let's work in way for a second just to see it. All right, any questions over here? How we doing? How we doing? Looks good, looks good. The magic for the front end adaptation is basically like every time you compile and deploy over here in your hard hat node, what's created are called artifacts. And that's an address of where the contract landed and also an ABI, which is like, it's kind of like an API. It tells you like, here's all the functions and here's all the arguments that go into that function. And you get that out of hard hat. So what the front end does is it imports that ABI and it gives you this nice form and it kind of auto fills in, right? So that's how that front end magic works, is it's just parsing the ABI and giving you a nice form over here. Okay, the thing I wanted to do is set my balance to 100 way instead. Now, if I hit this button, that E should go away. Yep, it did. Okay, so there's 100 way. And heck, if you were writing a token, maybe you'd have some function called transfer, right? And there would be an address to, and then a UINT 256 amount, right? And then it would be public. And what would we do? We would basically say that the balance of the message.sender would be minus equal the amount, right? And then the balance of the to address would be plus equal the amount. Isn't that crazy? We just made a token. Obviously, the ERC20 token standard is a little bit more complex. There's approvals. There's probably some checks here to make sure. The fact that we are using Solidity 8 means that if this underflows or overflows, it'll throw. So there's a lot of checks that we're not doing here that we had to do kind of traditionally in younger versions of Solidity. But that should work. Let's find out. There's only one way to find out. Yarn deploy. Here we go. All right. And let's see. Let's reload over here. I feel like the fact that it doesn't reload actually kind of like keeps a lot of stuff around. There we go. So now we have a transfer function. Okay. Let's bring up another jabroni again. Let's have them be over here. Okay. We kind of got like purple and green and purple and red, right? So let's send some tokens, right? We're not going to send any ETH. We're going to send some tokens to purple and green, right? So if we check our balance, it's 100 and it's 100 way. Remember, we're in way here. You got to be aware of that. But let's transfer to this dude 25 of our way, right? And send, and there it goes. So now if we check our balance, it's down to 75. And if we grab this dude's balance, it's 25, right? So there we go. That's a mapping. And that mapping can be any primitive to any primitive, and you can do mappings to mappings, and you could probably do mappings to structs. You'll get in there and get going on it. But that's how a mapping works, is it's like a storage element that lets you map one item to the other. The gotcha there is you can't iterate over your mappings. If you are creating a to-do list and you need to like iterate through things, then you'll have to use a struct and an array of structs, and it'll get a little bit more complicated. What does underflow mean? Oh yeah, this is okay. So let's talk about underflow for a second. When I was talking about that value, that balance, my balance, we can only hold so much, and this UINT is actually a UINT 256, so it's using 256 bits. But let's say we're only using 8 bits, then the biggest number we could possibly have is 255. And if you take 255 plus 1 in a UINT 8, it's going to roll over and the answer is going to be 0. It's all your bits, right? So you have 8 bits and they're all high, and you add 1 to it, it's going to go to all 0 bits, right? So you have like 1, then you have like 2, then you have 3. You know what I'm saying? Thinking of your bits. I probably did that backwards. It's probably, I don't know. But overflow is basically thinking of it like an embedded controller that only has so many bits to control your number. Those bits can get flipped by basically being, once they get all the way to the point where they're all full and you add 1 more to that, it rolls it over to 0. And that's how that unit works. But thankfully we had safe math before, and we have safe math kind of built in natively in Solidity 8. So if that rollover happens, it will throw an error and not let you get through there. Okay, let's see, where are we here? We learned mappings, right? Where is the repo? There we go. The next thing to learn is structs. Structs let you create a structure of other primitives, right? In this case, you have a to-do list, and you create a string and also a Boolean complete that goes along with it. And then you can create an array of those strings. And there's multiple different ways to add things to that array by kind of creating them and pushing them onto that array. But then what you can do is you can kind of iterate through those or access specific to-dos and set them to completed. Yeah, here we go. Here's toggling. So here's a toggle complete function that takes an index. So you'll have to-do 0, to-do 1, to-do 2, to-do 3. And then you're like, okay, I want to mark to-do number 3 as complete. You'll pass 3 in here. It will go grab that to-do, and it will say to-do complete equals, oh, it toggles it. Yeah, not to-do complete. Interesting. But it does it, right? I mean, if you're somewhat of a programmer, you can kind of dive in and understand this stuff. And it really is a good mental model to kind of just think of these as like embedded controllers, right? What the bits are doing underneath there, right? Hopefully I was a TA. I was a TA in college. I was the TA for the electronics course, and I enjoyed it. Okay, here we go. So modifiers. This is another thing we were talking about, how maybe we have this ownership pattern here. Eventually, you can build these modifiers. So instead of checking this require statement every time here, we can add something else here that's like only owner. And then it basically goes to the modifier, make sure everything is right, and then goes back to your function. You'll learn it as you go if you haven't already. Then events. Events are like cheap storage. So storing things on chain is super expensive. But if you don't need, if you have one smart contract that needs to talk to another smart contract, you can't use events. That's kind of the gotcha with events. Events are only meant for kind of off-chain reading. And it's basically like if you have a front end, right? And you have a smart contract doing things, and you need that front end to update. The front end is probably like doing a lot of polling and saying like, what's your balance? What's your balance? But also like every time you deposit and withdraw, let's say, you want to trigger an event. So then in the front end, when someone lands, it doesn't just show their balance, but it shows like, here's a ledger of all your deposits and withdrawals. And you don't need another contract to read that stuff. The other contract just needs to make sure their balance is there. But that nice log of deposits and withdrawals is like a cheap storage on chain where you can ask the contract for it. But again, the contract to contract interaction can't work through events. So events are a good way to have cheap storage for your front end, but no contracts. Okay. Then inheritance. Inheritance is so powerful here, right? We make one smart contract here, right? And we set this up. Oh, I can explain inheritance pretty easily. We've got this right here. We were talking about this ownership pattern where we had Austin, and then we had this require statement. We even talked about that modifier there. But let's say that like I don't want to rewrite my own ownership every time, right? What I can do is I can import an ownable contract from OpenZeppelin. And I can do something like, I think it's is ownable. Right there. Okay, so now I've inherited this other contract. So my contract is going to have all this other stuff from that other contract. And let's just get into it. Let's like take that dude out. Let's take our balances out. We don't need balances anymore. Take our transfer function out. What I want to show specifically is that we want this to be only owner now. Okay, and if I deploy that, Now, instead of me writing this whole ownership pattern, and ownership is easy, you have one owner, you make sure the owner can only do things. But say this is something more advanced, like you want it to inherit an ERC 721 and then have some more stuff there, or say you want to inherit role-based access or a handful of really wonderful things that you can get from OpenZeppelin. ZEP, here we go, here are the contracts. There's so many things you can get from these OpenZeppelin contracts, but inheritance lets you take a smart contract that someone else has written and just inherit it in. And since we did inherit it, look at this. So now we've got some new things. We've got this renounce ownership. We've got transfer ownership. So it's built in, and we have the owner, and guess what that owner is? That owner is that deployer, right? It's that same account that we're using for the faucet. So inheritance lets us bring in other contracts that have a lot of eyes on them that are written by some gigabrains, and we basically just use them, right? Like you still want to audit this, if you're going to have a lot of money on it, if you're going to mainnet, you still want to audit it, even though you're bringing in other people's contracts. But these contracts are a lot safer than just like Austin YOLOing an ownership pattern, right? Instead of YOLOing an ownership pattern every time, you can inherit someone else's ownership pattern, and it's at least safer, right? But still do an audit there. Okay, so that's inheritance. That's how you can bring in other contracts and inherit them. And we'll see if I take that out and we redeploy, we should see the renounce ownership and the transfer ownership disappear. We'll lose that functionality. There we go, and the owner. There we go. So we're back to, just by not inheriting that, we're back to our contract. What's next in the curriculum? Payable functions. I think we hit on that just a second ago when I made that function payable, and then we could pay money to set it. And then a fallback function is really cool too. It's sort of like your smart contract, this vending machine, can actually trigger some execution if money lands in it. So if someone just like YOLOs money to the address of the contract, it can actually execute some code. Maybe we're going back to that bank contract we were talking about earlier. Maybe someone, instead of calling withdraw and deposit every time, maybe someone wants to deposit funds by just sending money to like bank.austingriffith.eth, right? You could set it up so it catches that money, it figures out who sent in, and it increments their balance in some kind of mapping, right? So that's a fallback function. There's a lot to it, but these are kind of like the main aspects of like what you should learn to get started. And then it's time to kind of like test your knowledge. So I have this whole Ethereum Dev Speed Run. And if you have a Web 2 developer that you know that's thinking about getting into Ethereum, just tell them to Google speed run Ethereum. Just tell them to speed run Ethereum, right? Hopefully this article will be at the top of that. And what this article comes from is, first of all, it starts with Scaffold-eth. It helps you get it installed. It takes you through that exact same curriculum we worked through. But then I found that like that syntax is easy. You can get Solidity down pretty quickly if you're a decent developer. The thing that you need to understand is kind of like what the gotchas of Ethereum and where it's powerful and where it's not powerful, right? And so through a bunch of one-on-one mentorship sessions, I'm able to kind of like inform a kind of curriculum here where this was the stuff that I needed to teach, and this was the aha moment, and this is what helped make it easier for a new builder to get in and build stuff. So after you get a sense for the language, try out the simple NFT example. It's just going to have it's going to be a Scaffold-eth setup, so everything is where you think it is. Like you've got your packages, you've got your hard hat, you've got your contract, right? But instead of your contract, it's your collectible. And look at this, we're inheriting ERC 721. There's a mint function. We're setting our base to IPFS, but this is it, right? This is an NFT. This is all it takes to make an NFT these days. Thanks to OpenZeppelin and other folks in the space that have created all these composable elements for us to inherit, right? Ooh, that's really small. Can I zoom in a little bit? Let's zoom in a little bit and see the guts of that 721 there. There we go, right? So we're going to keep track of some little counter that's going to be a token ID. We're going to increment that thing. We're going to set our current ID to that. We're going to mint it, and then we're going to set that token URI. That token URI is that unique data. That's the thing you're actually owning, right? It's kind of an ownership pattern there. So that's the first quest, is just to build a simple NFT example. Then you can extend that simple NFT example if you want, right? Like maybe figure out a way so the artist doesn't have to pay all of the gas. Maybe figure out a way so the artist can set up a gallery, and then whoever wants to buy something from that gallery, they actually pay the gas to mint, right? And then maybe add a price function, maybe add a price curve, right? There's a lot of fun things you can do just in tinkering around. But when you're ready to test your skills, when you're ready to say, like, am I ready to go work for a Web3 shop? Am I ready to start building my own project? You're always ready to start building your own project, and you should be building lots of projects and throwing them away all along the way. I'm just gonna like pause there and zoom in on that. Hackathon builders. I was there. I was a hackathon builder. I was really married to the idea of creating pogs on the blockchain, and I spent months building this thing, and no one really cared. And what I should have done is iterate more. I should have built it out, tried it out, didn't work, throw it away, build something new, try it out. You're going to build and throw away for a while before you hit something that's like really a banger and it really resonates with the ecosystem, either mainstream audiences or crypto audiences. But just have that in your front pocket, that like, don't be too married to the idea that you have exactly working out. Think more like, what I need to do here is sharpen my skills, and I need to learn how to build. Just learn how to go from 0 to 1 a few times, and just by getting that skill down, you'll get hit hard with like, oh wait, I can do anything now, right? And people will be like, oh, I want to do an NFT project. Be like, yeah, I did 3 yesterday. Like you get to the point where you can iterate and you can really whale projects, but don't get too married to those ideas. Think about iterating, think about building and throwing away. Okay, so you're ready to test your skills. You're ready to go. The curriculum I've created really zooms in on why Ethereum and why not Ethereum and some of the gotchas. The first challenge is to build a decentralized staking app. So it's a full-on app. You'll turn in a URL, and anyone can go to that URL and they can stake some money into this contract. And the way this needs to work here, let's just go ahead and click on this. The way this needs to work is you need to build, a little too zoomed in. You need to build a staking contract that basically lets a bunch of jerks coordinate. You thinking of, you've got all these adversarial parties, and you need to get them to all coordinate financially. Like before Ethereum, the way to do this was like have some dude in the middle that's like trusted by everyone, right? There is like that breaks down, right? No one's going to trust that one person. The way you make this work is basically people trust the code. People trust the network. There's, $1 billion, many billions of dollar bounties on whether or not this network is going to fall apart, and it's doing pretty well right now. And then on top of that is your little code, right? So you have this nice decentralized network that you're building on top of. All they have to trust is this code right here. So even if you don't trust me, even if you don't trust anyone else participating, this is all you have to trust. You have to trust that this code is going to execute exactly like you said it will. So you want to build this decentralized staking contract to let adversarial jerks still coordinate and get together and all put in money. Let's say we need to raise 10 ETH to go buy some weird NFT, and we have 10 of us all together. We set the contract up, and it says each of us needs to put in 1 ETH. And if by next Saturday we don't have 10 ETH, then the state machine, right? Think of your smart contract as a state machine, goes into a withdraw pattern, and people can get their money back. And if we get enough people together by next Saturday, then there's a button that you can push that will basically move that money into the next step, the next phase that would go on to buy that NFT. And you want to build this thing so no one can steal each other's money. You want to build it so you have to get the right amount. You want to build it so if it goes into that withdraw pattern, someone can withdraw their money. Like, you don't want it to ever be locked, and you don't want anyone to ever have to trust anything other than, this Saturday is when the date is going to happen. And this, like, basically you can follow through that code and know exactly how this is going to go. So this is going to teach you payable functions. It's going to teach you kind of the why of Ethereum, really. It's going to teach you kind of like how you can put money into a contract. And that's challenge number 1. Then challenge number 2 is a token vendor. This is going to teach you about ERC20 tokens. It's going to teach you about contract to contract interaction. It's going to teach you about the dreaded approve pattern, right? If you want to send a token into a contract, you can't just send the token to the contract. You have to actually go to the token. Okay, so we've got two contracts. We've got the token and we've got the vendor, right? You've got to go to the token contract and you've got to say, I approve the vendor. Then you have to make a second transaction on the vendor that says, I would like you to go get some of my tokens, bring them back. And at that point in that line of execution, you know that you have those tokens. Then within that, I would like to do some other things, like maybe swap those tokens for ETH or something along those lines. So that's the approved pattern. It is particularly tricky, and that's why it's like in here, and it's something that you need to work through. But once you've got challenge 1 and challenge 2 down, you have a license to learn at this point. You're going to understand a lot more. You're going to start building a lot more. There's a bunch of other kind of side quests you want to go into. I have challenge 3 here. So challenge 3 is a little bit more open-ended. Either you build a DEX. So I would like fork the master branch of Scaffold-eth, and I'd go to this minimum viable exchange that I created here. And it's just an article writing through, talking through how, look at that jabroni, talking through how decentralized exchange work, why a decentralized exchange, why before, like when we had an order book system that could fall over, like what makes a decentralized exchange so powerful. And really, this is going to get into the code, and it's going to help you write. What I'm looking for is the price function. There's a really good price function in here that's based on the reserves. So the way this decentralized exchange works is there's some reserves that go in and you swap between the reserves. So that's going to be challenge 3. Then like make a dice game. Don't put it on mainnet, but make a dice game. Like play around with like randomness on a public deterministic blockchain is actually really hard to do. And you could do it pretty easily by just going and grabbing the previous block hash, but that's kind of not the most secure. And you need to learn why that is. Learn how commit reveal works. This can be used for voting, but it can also be used for randomness. But it's clunky, right? It takes multiple transactions, and it's kind of like you have to remember this thing and then reveal it later. And if you forget it or your computer dies and you lose it, then that doesn't work well. This is a good fitting talk for today. Is you can use an oracle, right? You can use Chainlink VRF. And by the way, if you're getting into Chainlink VRF, like go to Scaffold-eth, go to those branches, right? Type in VRF. Look at that. There's 2 different VRF branches. They're both NFTs. But VRF will help you get a random number. And the TLDR is there is you say, I would like a random number, and you pay a little link to Chainlink, and then they come back in a callback function with some randomness, and you can do some other stuff there. So learn randomness and learn why randomness is tricky. Even learn like why oracles are interesting and how the oracle problem works and how we make better oracles. Shout out to Chainlink. Then with the DEX we talked about, right? You can get into DeFi. There's a handful of really interesting things in DeFi, but I feel like the crux of what makes DeFi so important is lending. So understand how lending works, understand how you can borrow and how over-collateralized loans work and how liquidity providers works and how like when you provide liquidity and you get that LP token, you can then put that LP token in something else and it gives you another token and all the yield farming stuff that's really interesting. And with lending, you can leverage up, right? If I can put in 1 ETH and I can get 600 DAI. Oh man, those were the days. Those were not the days. If I can put in 1 ETH and get if I can take out an over collateralized loan, I can get some money back. I can swap that back to ETH, and I could take out another over collateralized loan, and I can get some money back from that. And I can take. You can kind of like lever up. Be careful. Like this is learning. We're learning here. We're not actually aping into anything. Not financial advice, etc. But you can learn how leverage works and learn how lending works and learn how shorting a token works and all that fun stuff in the DeFi world. One of the superpowers of Ethereum, these ECDSA signatures, is that we have, let's see, when do I finish? These signatures are really powerful. Basically, like your address, your username can sign a message, and that message can go across the network. It can be tampered with, whatever. But on the other side, using your message and your signature, someone can recover your address. And if anything is changed, it falls apart. So these signed messages are actually really, really powerful. Okay, we got 10 minutes. Here we go. We're in the closing 10 minutes. So signed messages are really powerful, and you can do a lot of stuff off chain with signed messages. Like you can open up a state channel with someone. Basically, you can be signing messages that go to them in a stream. Nothing's going on chain. As long as maybe that settles to a contract eventually, and they can take the last signed message and settle it. So there's tons of stuff you can do with signed messages. But the real superpower is being able to recover those signed messages inside of a smart contract. So you sign a message and you send it to the contract, and you sign a message and you sign a transaction. Let's say it that way. You sign a transaction, it goes into the mempool, it gets mined, it happens, right? But within that signed transaction, you could actually have another signed message. And so your transaction goes on chain and it puts that signed message into the contract, and then the contract can recover who signed that message. So there's all sorts of like weird account abstraction stuff where I can sign a message and I can give it to a relayer, and the relayer can pay the gas, and a smart contract can cryptographically check that it was me that signed the message, even though I didn't pay the gas, I didn't make the transaction, and it can do something on chain with my account using that signed message. So signed messages are really interesting. All of that leads up to you as a builder. First of all, if you get through the first couple challenges, reach out to me. I will sponsor you to get an ENS name, a .eth name. The next thing that I sponsor you to do is to get your own Gnosis Safe or a multi-sig. A multi-sig is a really good way to store funds. So you have a smart contract that holds the funds, and you have multiple signers that basically vote on transactions, right? So you basically vote on, like I propose that we send $5 to Austin, and that's one sign. And say it's a 3 of 5 multi-sig, you need 2 more people to also sign off on that. And this is a safer way to store funds. Instead of having funds in externally owned account, if you have multiple externally owned accounts that all have to sign off on something, that slows down that movement and makes it, safer. So the kind of like the final boss to beat in my speed run here is to build your own signature-based multi-sig. And you'll explore Solidity by example. Solidity, man. There we go. You'll explore Solidity by example, and you'll learn a lot of kind of like the concepts. But there's also down here, there's applications and there's hacks. Obviously, you want to get in and learn like all those hacks. Like, how does reentrancy work? How does delegate call? Ooh, delegate call. Ooh, it's scary, but and also very powerful. But get in and learn the hacks. But you also see this multi-sig wallet here, and you'll notice when you get in here, it actually keeps a struct of the transaction. And for each transaction to work, basically, it's proposed and it builds a struct, and each person who votes makes a transaction, and it ends up being like if you have a 3 of 5 multi-sig, it ends up being like 5 transactions before you actually execute anything, right? The way this signature-based multi-sig works is it's all off-chain, it's all signed messages. You propose, and it saves that in a backend somewhere, even IPFS, and then other people can go get those signatures and try them out. But basically, you collect 3 of the 5 signatures, and you call one function on this contract once that says, I think we could send $5 to Austin, and here's the array of signatures of enough signers that say that we can get into this. And there's some gotchas in this contract that will catch you if you're not paying attention. So this is the final boss. If you haven't built a signature-based multi-sig, you should do that, and that's a good place to start. So going from that, if you are that auditor level person, another thing I would recommend is getting in and taking on the Ethernaut DAO, or the Ethernaut, not just the Ethernaut DAO. I think it's just Ethernaut, right? Yes. If you're thinking, I would like to get into this low level EVM stuff, I'd like to learn more stuff, this is a requirement. You got to whale the Ethernaut DAO. If you're thinking, I want to build my own app, you probably want to just maybe go through the speed run. If you're thinking, I just want to get in, I want to work in Web3, I would say take on the first few challenges and reach out to me, and I can connect you to a handful of places in the space that are looking for builders that like at least need about those 3 challenges worth of knowledge, right? So there's kind of a couple different paths you can go on. But for me, and my advice is it all starts with this Ethereum Dev Speed Run, and it all starts with tinkering with Scaffold-eth. So let's say you're in that middle path, right? You want to build your own project. You're thinking about what do I want to build? How does it work? You've gone through the speed run. You've gone through the tour of duty. You understand randomness. You understand contract to contract interaction. You understand these challenges. Now it's time you want to build an NFT lending app, right? Where do you go? How do you get started? So I would start with Scaffold-eth, right? Let's go to these branches again, right? If you type in NFT here, holy moly, look at all these NFT. Is there actually a lending one? I bet I can. There's an auction. There's a signature-based auction, randomly revealed NFT, Nifties versus Nifties. That's a throwback. Ooh, SVG NFTs. We got to talk about that. How much time we got? 5 minutes. It's getting tight. All right, here we go. We definitely need to talk about that composable NFT and SVG NFTs because they're so fun. But whatever the project is you want to build, get in and check out these branches. A second place to look is the Build Guild, and this is kind of my funding and incentive mechanism. So there's a ton of generic components. The Build Guild is an Ethereum public good. It's a bunch of builders that are loosely affiliated with me that are building generic components, prototypes, tutorials with Scaffold-eth. You can get in here and find all these cool prototypes, like a nifty viewer. There wasn't a good branch. I couldn't easily fork something and make an NFT gallery, right? So much of Web3 people is starting from scratch where everything's open source, everything's composable, everything's on chain. We should do a better job of making things hella forkable. So it's so easy to get in here and just take it to the next step. So there wasn't a good one of those, so we made one, right? And there's so many other things in here. One of them is a signature-based NFT auction, right? Or sign in with Ethereum, right? Vitalik was talking about, not that one. Vitalik was talking about how we need to make a sign in with Ethereum, sign in with Web3, right? Here's a perfect branch that does this. Basically, it's all of Scaffold-eth, everything you're used to, and then there's a backend, and you sign a message and that goes to the backend, and the backend recovers that message, proves it was you cryptographically, and then maybe it checks to does this guy own a Meebit? And if he owns a Meebit, then we take him somewhere else or we give him some other content. So you could do token gated content, you could do all sorts of stuff with this little starter template. So whatever you're thinking about building for your project, I would urge you to get into Scaffold-eth, tinker around with it and understand it, but then look through all these branches. Look through what the Build Guild is building. Look through what the Moonshot Collective is building. The Moonshot Collective has this great org here. Moonshot Collective is very similar to Build Guild, but it's over on with Iwaki from Gitcoin, and we're building a bunch of DAO components, and we're finding kind of how do we pay out to a DAO? How do we pay people in a DAO in a decentralized way, right? So we're building a lot of those tools here. A lot of those are Scaffold-eth based also. All right, last 2 minutes, the thing I'm most excited about. So you can find all sorts of stuff here. Great resources. Hopefully, I think I didn't see any questions. If there was a question I missed, throw it in there another time. The thing I'm most excited about is this idea of composable NFTs. So there is a composable. Okay, so first of all, Loogies. What do we have? 2 minutes. Let's go to loogies.io. Scaffold-eth app. Okay, so also Nifty Inc., right? Going back to cool NFT apps. This was built with Scaffold-eth 6 months ago, right? This helped us inform kind of what we want. Oh, a lot of penises on the front page. My bad. Okay, it helps us inform how we wanted Scaffold-eth to work. So this is just another NFT app built with Scaffold-eth. In this case, we used burner wallets. A lot of times you carve the burner wallet out. We actually brought the burner wallet in here. Okay, Loogies. Loogies are an SVG contract. Actually, I want to see. Let's go Loogies here. Let's search for Loogies. Oh, I don't see them anywhere. So we have Loogies. Loogie SVG NFT. Okay, here we go. I want to show this one thing. Everything is in the same place, right? Hard hat, contracts. Here's our collectible, right? And look at this. Look at this. It's actually rendering the JSON right here, and it's rendering the SVG here. Look at this. If I zoom in here, there's a render function that builds an SVG. And what we found, once we had this cool SVG where it would render, it actually renders that little, it's my Twitter icon, right? Let me just go to Twitter here. This, where's my profile? This dude right here. Yeah, that's a Loogie. Has a width, has a color. has a chubbiness, right? All that is built in, like the chubbiness is on chain, right? We're using the chubbiness on chain and we're drawing this thing. So the thing that I'm super excited about is once we realized that we have this render function, we decided that, oh, what if like one NFT could own another NFT? And if this render function is public, then what we could do is we could have an NFT that you send in to this. So this is the composable NFT branch. It's open source. It's super forkable. Go check it out. But what we did was we created these loogie tanks, and it's an NFT itself. So you've got loogies over here, and you send the loogies into the tank. And then the tank itself, when its render function is called, it actually looks through all the loogies it owns and it renders them by calling their render function. So the parent calls the render function of all the children and collects all the SVGs. Then we added a little animation in there and we made it random based on block hash. So you see them swimming around and their location is deterministic. So if you go to the loogie tank and I go to a loogie tank and we see them on OpenSea, they're going to be moving around exactly the same, deterministic from the blockchain. It's so crazy. So I can't wait to see what we do with composable SVG NFTs. And this whole gaming world is going to open up here with L2s, a lot of EVM compatible networks. Yes, this is not just on chain. Like this is being drawn on chain. The JSON is being drawn on chain. The SVGs are being drawn on chain. One NFT owns the other NFT and on chain renders all of them. So all of that is like actually coming out of a smart contract. Okay, hearts. Thank you guys for having me. Remember Scaffold-eth, just Google it. You can find it. Remember the speed run. If you have a developer, not ETH build. If you have a developer that is thinking about getting into Ethereum, tell them to go speed run Ethereum. All right, thank you guys very much. Hearts. Go speed run Ethereum. Go build on Scaffold-eth. Reach out to me on the DMs. They're open. Especially if you work through a couple of those challenges, then I'll jump on a Zoom call with you. I'll help mentor you. I'll help direct you to somewhere else. Just get those first few challenges done, and then I'll always jump on a call. Thank you very much, everybody. I think my time is up. I'm probably into someone else's time. I hope we're okay. I'm not seeing anybody else in the chat. So I think I'm just going to log out. Hearts. See you guys later. Thank you, Patrick from Chainlink, for all the work that he does. Thank you, the Chainlink community. Thank you to Chainlink for building awesome stuff and having this hackathon. Go hackers, go build. My DMs are open. Get into the Scaffold-eth chat and ask questions. Speedrun Ethereum, get Scaffold-eth pulled down. There's so much fun stuff to build here, and there's always so many exciting things on the horizon. So just get in and keep building. All right. Thank you, guys. Hearts. See you later.